Well, welcome everyone to this afternoon's session of building home security solutions at scale, featuring Comcast. I'm Charlie Hamill, Solutions Principal Enterprise Architect with AWS, and joining me today from Comcast are Anandan Subbiah, who's VP of Digital Home Platforms at Comcast, and Lawrence Reeve, who's Senior Director of Camera Platforms at Comcast, and they'll be coming up in a moment. So today we're going to take a look at the connected home market, a bit of a dive into AWS IoT, Kinesis video streams, and then we'll tell the story of how Comcast has actually done some of this at scale. So to take a look at the connected home market, I want to bring you back a few years, like 3 years ago, when I was at a conference and heard Marcus Weldon, who's president of Bell Labs, speak. And he was launching a new book that he just published. And it's the first time ever Bell Labs has ever produced a book. But they thought the subject was so important. And look at the statement he made. He said, "We're at the nexus of human technological revolution that will be more different than any other prior era. It will be simultaneously global and local. And the innovation will be occurring everywhere, and the coming global-local collision will produce ideas that make this technological revolution one of the most fruitful and far-reaching in human history." That's a really audacious statement, but that's how much they believe in what's going on. He's talking about the proliferation of connected devices. Believe it or not, to them, it's all about what's going on with IoT and other things. And it's exploding the capacity of just about everything. And the key word here in this statement is human, because a lot of this activity, in fact, most of it is driven by human behavior, not automated systems behind the scenes processing stuff, but human activity. And here's some of the data he uses to back up the statement. This is a pattern of core network traffic since 1970. And you see that from 1970 up to about 2005, not much moved the curve. That's all through the mainframe era and then PCs and client server, even the early internet, didn't do much to move core network traffic. Then you got into the e-commerce era, and that started to move things a little bit. Social networking, social media began to pick up then. And then when you started to get into more media-intensive things like 4K video, Instagram, Snapchat, things really started to move in an exponential direction. So back in 2015, kind of around when Marcus Weldon wrote this, it started to continue in an exponential direction, so he thought. By next year, it was supposed to be about 2.6 zettabytes a year just in the US on the core network. Already we're seeing it's not that at all. It's almost double that. And that's all because of all this human activity that's going on with connected devices. And what sectors are contributing to this? Well, the number one sector is consumer-driven activity. That would be your mobile devices for sure, automobiles, and things in your home. And it's making a really significant impact to what's going on in the network. So that's the setup for why we need to talk about Internet of Things and streaming video today, especially in the home. In the home, we've got three major use cases that are going on. Home automation, which is about lighting systems and white goods and appliances, media and entertainment, and sound bars and things like that. And then under home networking, we have Wi-Fi routers and modems and cable boxes. Then in home security and monitoring, which is where our focus will be today, we have things like security cameras, door locks, door sensors, motion detectors, water leak detectors, and smart meters. But building a connected home solution is difficult. It's difficult to quickly build and differentiate products in a crowded market. And if you're building solutions for that market, you really have to think about innovation because there's so many Me Too players in it. How are you going to stand out? And secondly, it's challenging to improve customer experiences, which you ought to be constantly doing, while keeping costs low. And then thirdly, it's hard to maintain interoperability between so many different vendors' devices in the home. And next, you need to ensure devices work regardless of local connectivity. And also, you need to deal with a lack of reliable and scalable cloud infrastructure to run your applications. And then lastly, you need to ensure that you're compliant with regulatory issues and that everything is secure. And on top of that, building a video system is tricky. One of the components we saw in the list of devices in the home was a security camera. And customers aren't happy with just that storing locally, maybe for DVR playback, or hopefully they might see the thing live. They want to see it anywhere, anytime, wherever they happen to be, which means it has to leave the home and stream into the cloud somewhere. And building that kind of an infrastructure is difficult. It's cumbersome to rewrite code for various devices and development environments. You need easy-to-use APIs to retrieve and replay and process video at scale, and requires reliable support for cadence, latency, and jitter on streams. And it's difficult to elastically scale to millions of devices. And if you're not elastically scaling, you're provisioning to peak, and that's really expensive. And we hope you got the peak right. The next thing is that it requires secure streaming and storage by default. You don't want this video getting into anyone else's hands other than the homeowner. So to summarize what we've said so far, we are in a technological revolution. The data kind of says so. You need to innovate in order to differentiate yourselves, and you need to do it quickly. But there's one other trend that I didn't mention, and it's probably the trend that got most of you here today, and that's the cloud. And I'm going to talk to you now about a couple of AWS services and families of services that will help you tackle all three of these problems. This first one I want to talk about is AWS IoT. AWS IoT is a family of services you can divide into three categories. The first one is data services, which helps you answer the question, how do I get value out of my IoT data? And then the second category is control services, which is how can I control, manage, and secure my devices? And then the last category is how can I manage devices and operate at the edge under device software? Specifically, on the top category, at the base, we have AWS IoT Analytics. And on top of that runs AWS IoT Sitewise and IoT Events. In the second category, we have at the base the AWS IoT Core. And on top of that runs IoT Device Management, IoT Device Defender, and IoT Things Graph. And then in the last category, at the base, we have Amazon Free RTOS, which is a real-time operating system for microcontroller-based devices. And also AWS IoT Device SDK, which helps microprocessor-based devices interact with the IoT stack. And on top of that runs AWS IoT Greengrass, which is a framework for running applications in edge devices. So why use AWS IoT for home security and monitoring? One of them is machine learning and inference at the edge. With IoT Greengrass, you can run machine learning models and applications in edge devices, tiny little CPU-based devices like routers or cameras or home hubs, doing machine learning inference on things that you want them to see and decide on. And also, as that model continues to do its job, it's always sending data back to our machine learning framework called SageMaker, which can take in the results of what it's inferring and constantly improve and refine the model as it's in use in production. Next, you want offline communication. So with IoT Greengrass, it enables connected devices to operate with intermittent network access, resynchronizing when it gets a network connection again. It doesn't stop. And you also want a quick response time. IoT Greengrass devices can process and act on data locally and respond quickly to local events, which is what the homeowner wants. without making a round trip to the cloud, which may or may not be there. And Amazon free RTOS devices can easily connect to Greengrass core devices in the home. And next, you want intelligent insights. So with IoT analytics, you can actually easily gain predictive insights about device usage patterns, and so that you can make adjustments to your deployment, to your applications. And you want to scale securely scale. And AWS IoT is built on a scalable, secure, proven cloud infrastructure that scales to billions of devices and trillions of messages. And AWS IoT includes preventative security mechanisms such as encryption and access control to devices. And it also offers a service to continually monitor the device posture of your devices, the security posture of your devices, so that should anything go out of where it should be security-wise, you can redeploy patches and get things right again, so they stay secure. And then lastly, you want a rapid time to market. So AWS IoT offers something called a things graph, which is a way to visually design complex applications across many devices and then deploy it just like that, as long as those devices are running IoT Greengrass. So here's a picture of the front door of a house. And on the left, you have a security camera. And on the right, you have a smart light, and then a video doorbell, and a smart lock. So the camera can actually be running a machine learning model that detects or infers that there's an intruder there, a non-family member, and no one's home. And it can alert the homeowner at that point. The smart light can detect light changes and come on or go off, or the presence of motion and come on or go off, and also enable the homeowner to control the light remotely. And a connected door lock and video doorbell enables the homeowner to allow a guest in the home when they're away. So let's shift over to that other service, group of services that I wanted to talk about, which is going to help you innovate faster and focus on innovation instead of the core infrastructure. And that's Kinesis. Kinesis is a family of streaming services. You might have heard of Kinesis mostly in the data world. We have Kinesis data streams and Firehose and analytics. But also we have Kinesis video streams, which is a video streaming framework. And the way it works is on the far left, you might have a video device, a camera, a motion camera, or even audio. And that is able to run the producer SDK, which enables that application to easily connect to the Kinesis Video Streams API and stream video at it continuously. And then the Kinesis video streams can deliver a real-time stream of video to a consumer who's using the consumption API for real-time streaming to a display somewhere. But thirdly, it also durably stores the video and indexes it so that any consuming application can come along later and retrieve a segment of video for playback after the fact. So why use Kinesis video streams for home security and monitoring? Well, one reason, it's a fully managed service. And in this case, it's a service we like to call serverless, meaning your only relationship to it is through an API. There's no infrastructure for you to manage, no infrastructure spun up in your VPC. It's simply a black box API where AWS manages all the infrastructure. You don't have to worry about configuration, software updates, failures, or scaling infrastructure as the number of streams you throw at it grows. Next is streaming. You want to be able to stream video from millions of devices. You need that scale. So Kinesis video streams can ingest data from edge devices like smartphones, cameras, and other devices such as radars and LiDARs, drones, satellites, dash cams, whatever. And it provides you searchable index storage so that you can use SDKs to consume easily consume the video from an application you're creating. You can easily build vision and vision-enabled apps with real-time computer capabilities using another AI ML service we have called recognition video. You can stream video at recognition video, and it will find objects in it for you in a very narrowly well-defined way, as opposed to an open custom machine learning framework you might build. And then lastly, Amazon Kinesis Video Streams enables you to control access to your streams using AWS Identity and Access Management, or IAM. And it helps you protect your data by automatically encrypting the data in flight and at rest, using KMS for Amazon's key management service for encryption keys, and also TLS for encrypting the data in transit. So here's a use case using Kinesis Video Streams. Let's say you want to create a pet monitor for homeowners. So they've left the day for the day to work, but they'd like to keep an eye on their pet at home with their mobile device or from their desktop through a web application. The way that would work is over on the far left, you could have a camera with a machine learning model running in it, as we've already talked about, and that model could infer when a pet is present in the scene. And only then would it stream video over to Kinesis Video Streams, so that only the video with the pet in it gets to Kinesis Video Streams. A video processing application can pick that up and stream it out to a mobile application or a web application so the pet owner can see it throughout the day. Let's talk about how we can put these things together. So the use cases for why you would want to focus on AWS IoT and KVS together is that you want to focus on differentiation. We've mentioned that a number of times. But in this very crowded, competitive market, you need to move up the value chain to where you're doing what only you can do. Anyone can do this other stuff we're talking about. It's not that distinctive. And your customers, frankly, don't care how you're managing their devices or how you're streaming video to them. They do care about the features they see that only you create. So focus on differentiation, and you can do more of that the more you're focusing on the key applications that set you apart. Secondly, it's cost effective, because with the pay-as-you-go model that we have at AWS, it allows you to innovate new customer experiences while keeping the cost as low as necessary for the scale you're running at. And thirdly, with flexibility, you can perform various messaging protocols, and you have a vast partner network allowing you the flexibility to build interoperability between multi-vendor devices. With local connectivity, edge-based computing can help you build innovative, intelligent products that work regardless of network connectivity. And with scale, AWS IoT provides a reliable and scalable infrastructure, and Kinesis Video Streams can scale to many millions of devices streaming at the same time. And for security, AWS provides built-in security for complete protection from the edge to the cloud. So here's another view of everything we've been talking about. On the far left would be the home. So there's a stack of devices there, starting at the top with microprocessor-based devices like a security camera, a Wi-Fi router, a home controller, all running IoT Greengrass. And then below that are the microcontroller-based devices like a door lock, a light bulb, small appliances, all running free RTOS. And with that, these devices are able to interact with the AWS IoT services in the cloud and with each other. And then with Kinesis Video Streams, that security camera can stream video to the cloud as well. Once in the cloud, in the world of the IoT stack of services we're showing there, you then have access to other AWS services like machine learning, databases, compute, and more. And with that rich infrastructure, you can build customers-facing applications like mobile applications, dashboards on a web interface, and even Alexa devices for humans to control things. I'm going to show you now a couple of reference architectures that go into this in a little more detail in a particular use case. The use case here is, let's say we only want to know about pets. We've already talked about that a bit. So here's a way where you can actually deploy that. This first way is going to be a fairly conventional way where the machine learning and processing is happening in the cloud, not at the edge. So at the top, number one, we're showing SageMaker, which is an environment where you can build, test, and optimize a machine learning model, then deploy it to some computing environment. In this case, because it's the cloud, that computing environment is going to be a GPU instance, which is a very powerful processor for doing machine learning type computations. We're expecting a very large number of streams coming through here, so that's why we picked that type of instance. And in order to interact with that, you would need some ongoing, ever-running application, let's say running on Fargate, which is kind of a serverless way of giving you a container environment. So going down to the bottom at number 3, we have there in the home, let's say a camera. And that camera is running IoT Greengrass and a Lambda function, and it's able to detect events in the camera. And it's also able to retrieve the streams coming from the camera and send it out the door. So what it's doing here is the events will be telemetry that it sends to the cloud, to AWS IoT core. And from there it goes to Kinesis data streams, into an IoT channel, which goes to IoT analytics, and then IoT events, which are if-then-else statements that decide whether something is noteworthy. Going to the bottom part you see there is where the video is coming from the camera. It's all video now at this point, and it's going to Kinesis video streams. Kinesis video streams has a consumer, which is a Fargate, or an application running on a Fargate cluster, and that happens to have access to that machine learning model we developed up on top. So that's actually running on a powerful instance, a G3 instance, and all video frames go to that endpoint for the machine learning model to infer whether it has a pet in it or not. And based on that inference, the application running in Fargate decides what to do. Send the frames forward to another application, send events about it forward. It's up to the application. Let's take a look at this flipped around a little bit. Here's the whole thing flipped over to the edge. So starting actually over at number 3, there's the SageMaker environment where you could build the model again. But using something unique to SageMaker, you can produce that very same model at 1/10 the size it would normally be, using something called SageMaker Neo. And you can deploy that model now on a tiny device on the edge. And let's say we've got a device here that has the Greengrass core stack in it. It's got a Lambda function. It's got the machine learning executable running on it, and images can come to it. Now let's go down to the bottom to see it actually deployed in a home environment. So starting at number 6, we have that same stack again, and let's say it's all on the camera at this point, and the machine learning model is inferring whether the image is a pet or not, just like before. But it's happening in the camera here. And when it infers that it's a pet, it emits a telemetry event as well as the image. The telemetry event goes across the top there as we saw before, but this time just the pet images are going across to Kinesis video streams. And there you'll see it goes directly to a display application, a mobile application, for instance. No GPU instance. You're taking advantage of the huge network of edge devices you've got to do the machine learning work. So lower impact on the network, lower impact on the cloud as far as your expenses to run a machine learning image. That may be appropriate. It may not be appropriate, depending on what you want to do with the video. So what have we talked about so far? We've talked about the technological revolution that's kind of a big deal. And we've talked about the need for you to innovate and innovate quickly. And I've shown you how a couple of AWS families of services can help you do all that. But now, Anand and Larry are going to come up here and tell you how Comcast has actually done that.
Thank you, Charlie. My name is Anand Subaya, and I'm here with Larry Reeve. We are part of the Digital Home organization back in Comcast. So what we would like to do today is to give you a brief overview of the Comcast camera portfolio, the genesis of the camera platform, which is specific is the continuous video recording platform that we built. And ultimately, we'll talk about the Comcast AWS IoT core and KVS integration. So when we first launched the camera platform, before that, I think most of you must be well aware of the fact that Comcast has a huge presence in both the broadband and cable space. But we also have a home security offering. It's called Xfinity Home. And as part of Xfinity Home, we allow our customers the ability to purchase cameras from us, right? So when we first launched cameras, the only thing we offered them was live video. And then we took a break, and then we decided that the best thing to do to remain competitive in that space is to build a continuous video recording platform. So let's talk about that for a second, right? So when we initially started building the continuous video recording platform, we did it with OpenStack and Ceph as a storage backing it. The primary reason behind it was this was done like 5-6 years back, and Comcast had an investment in OpenStack, and it was pretty much the internal cloud that was provided to us. The one thing we realized as soon as we started doing the project, the POC did work well. We built a bunch of microservices writing to Ceph as a storage. What we figured out pretty fast was the fact that even though compute was an easy problem to solve, storage was difficult, right? I think we needed a dedicated team to support us to actually build something at this scale. At that point, due to conflicting priorities within Comcast, we could not get a dedicated team to support us in this endeavor. So we decided to go with the public cloud provider at that point. So the architecture that we did not change much, but all we had to do was optimize what we did to work with the storage system that the external cloud provider gave us at that point. So we were in production, to be honest, with minimal issues. Larry will actually walk you through some of the design elements there. So I'm just giving you a high-level overview. So at that point, we did not have any production issues for 2 years. We were sailing smooth. 2 years after the fact, I think this was at the beginning of last year, Comcast made a strategic move to stick to one cloud provider. And the preferred cloud provider we chose was Amazon, obviously, right? So the change that we had to do, again, was very minimal in the sense that we had a microservice architecture that just got ported over to Amazon with minimal changes. And the only thing we had to do different was to use a different storage. In this case, it was S3. So again, the team actually blew through it. We were able to make the necessary changes, just optimize our code base a little bit to work with S3. The main difference was, at least from a development standpoint, the tools that Amazon had for managing the infrastructure was very mature. So the team actually loved and enjoyed working with the mature tools that Amazon provided. But the side effect was within a month or two, we realized that writing to S3 directly, that too with a product like which is going to continuously write video fragments to the cloud, was not it was an expensive proposition, right? It was much more than what we used to pay the previous vendor, to be honest. So what happened at that point, we worked with Scott, I don't know where he is, there he is, and then we worked with Girish from Amazon, and we had to find a solution to reduce cost, right? And the BU was putting us under a lot of pressure because that was not a sustainable proposition for them. So what we came up with after multiple discussions with the team and multiple iterations to figure out what's the best way to reduce costs, we decided that migrating our continuous video recording platform to work with IoT Core and KVS was the best path forward. So what that actually meant was, off the bat, we saw a 25% reduction in cost. I think we don't have the numbers yet. We are right now at 25% in production right now. We anticipate those numbers to be higher. But writing directly to S3 versus writing to through the managed service KVS guaranteed us a minimum 25% operational reduction cost. So this was a huge deal for us, and I believe that will be the same case for any business. So what this also meant, in terms of motivation, is there are a couple of things there, right? So what this also meant was, we had a lot of infrastructure to support the video path, which is from the cameras writing directly to the cloud. So KVS as a managed service pretty much insulated us from that part right now. So we didn't have to worry about, they have a firmware running on the cameras. There is a cloud service. And all we had to do was pretty much use HTTP to interact with the cloud service to retrieve the video streams that we needed. Larry will actually walk you through the details. I know I'm rushing through this, but I wanted to give him enough time to talk through the architecture. So overall, the point I'm trying to make is, there are 3 benefits that we saw when we migrated from directly writing to S3 versus using a managed service. One is, obviously, like I said, the reduced cost. The second aspect is, the operational burden on the team got reduced simply because of the fact that we did not have to worry about the video path. It was available to us at a reduced cost, right? Even with the high-level service that we used. And the third was our use of IoT Core, right? It provided us a secure way to access the video stream. Previously, we used an internal registry, and Larry will walk you through that. But at a high level, I think this is the summary. So I'll let Larry walk you through the architectural design right now.
Thanks, Anand. So as Anand mentioned, we've been through several iterations of this platform, our continuous video recording platform. At a high level, the goal is we have customers that have home security cameras in their home, and they'd like to continuously stream the video out of those homes. And we needed a system to be able to continuously capture that, right? Pretty challenging problem. There's absolutely no downtime. We have to continuously stream all the time. So how do we capture that video and then store it and index and make it available for playback on demand? So our first iteration, I'll show two iterations. One is the one that we currently have in production. And that's a set of, on the platform side, a set of internally built services that are running on Amazon EC2 infrastructure and using S3 as the storage backing mechanism. And then the second iteration is when we started to look at how can we reduce the operational burden on the team and the cost of the platform. We started evaluating different ways to do this, and then we came across KVS and the IoT platform managed services to help us do that. But let me talk to you a little bit about the first iteration that we have that's currently out there. So there's a couple of core components that we have. First is obviously the camera. And so that's the video source that's continuously streaming on there, on the platform. We've got a set of cloud native services that we've built. And those services are responsible for onboarding the camera, taking video continuously, identifying motion events, and storing all that data, running it through some AI to identify things like pets and cars and so forth that we can then filter on in our playback experience. We have an internal device registry. That internal device registry is designed to keep the camera and the user, the account that it belongs to, identify those, do that coupling, put that together. And then also store additional attributes, such as is continuous video recording on this camera? Is audio enabled? Those types of attributes. And so that's something we've established as well internally. And then we have a playback service. The playback service is designed to support our clients. So we have iOS and Android. And we also have a web client and an X1 set-top box client. So we have multiple clients, and they needed a consistent API. So those are the major components of this system. There's multiple flows as well. So the first one would be, I have a camera. As a customer, I just got a new camera. I need to onboard that. So we provision that camera onto the account. And that's where we have established the configuration of the camera. And that's where we do the mapping into the internal device registry. The second flow would be that we now have video streaming up 24/7 up from our customer's home. So we need to store that. So these are HTTP posts that are coming up every few seconds with segments of video. And then we take those and then we store those into S3. We also index them, timestamp them, and securely store those videos and keep the indexing in Dynamo. So that's got a storage backing mechanism. The third aspect of this is that when the camera detects motion, which is of most interest to the customers, right? Most customers don't watch video continuously. They want to know, key things that happen. And so there's motion events that come up from the camera. Those motion events are captured. We store those. We also run them through SageMaker. We have a team that builds models to identify various things that are of interest to the customer. As I mentioned, things like pets and cars. And so you can be able to filter in the client to say, I only want to see videos with pets, for example. And then we also store those labels as well. And then on the opposite side, once we've got all that video stored and we got motion events identified, we then have our clients come in and show you, here's a list of all the motion events. And when you click on that, it then takes you through the playback service, back in, pulls the data out of S3, and then streams that as video down to our clients. And so that's been in production for a few years for us. It's been very successful. One of the challenges we had is this takes hundreds of EC2 instances, so quite a bit of infrastructure to maintain. It's a small team. So how can we reduce the operational burden? Obviously, this solution scales, and as we get new customers, the solution is designed to scale. It just means we have to keep adding more and more infrastructure to do that. So what we've done is moved on to looking at how can we integrate KVS and IoT. So again, we have the same set of components here, but we've replaced and augmented some of our components using IoT Core. So before we had our own internal device registry. We've augmented that to be able to store, so in IoT you would create a thing for a camera. And then we'd map we'd create a certificate, a unique certificate for each camera, so that we can securely, each stream is tied to that camera. And so we map the certificate into a policy and tie it to that camera, and then we create a secure KVS stream. And so that KVS stream is tied to that camera, like it's very secure coming out of there. And so that's a huge benefit for us that has helped us enhance our product in terms around security. The other flow that we had, where we continuously stream the video up, now goes through KVS. So as Charlie mentioned, there's a producer SDK. So we've integrated that into our firmware. So we own the firmware, which is a huge advantage for us, because we can quickly adapt and add new technologies into this. So we've done that. We've added a producer SDK into the camera. That's streaming now to KVS. So now we don't have to worry about any of the EC2 infrastructure for all this upload service that continuously handles the video. KVS is doing all of that for us. We still have the thumbnail motion events coming through. So that's still there. And we still run it through SageMaker, still taking advantage of that. On the playback side, we have, we still go through playback service. We found that it improves latency. If we can optimize some things in the playback service itself, so our clients still go through playback service. And then it also helps out with security. So this is a huge advantage. Again, we had hundreds of EC2 instances. We're able to drop down to tens of EC2 instances now. So it's a huge advantage for us operationally. So the key benefits that we've experienced. So as I mentioned, IoT Core provides a device registry that we're able to have policies associated with it and have increased security. We're able to leverage it to store additional attributes. A big thing for us is operational scope. How do we reduce the amount of infrastructure required? So as I mentioned, we went from hundreds down to tens. There's the operational costs, we're expecting at least 25%. We think it'll actually be greater than that, so which is also, from a competitive viewpoint, a huge advantage go to market. And KVS and IoT are managed services, so our team doesn't really worry about what's going on behind the scenes. We leverage Girish's team to partner with them very closely to make sure the service is at scale and what we need and so forth. So that's been a big advantage as well. And again, because we don't have to worry about infrastructure, the solution scales without us becoming involved. And then the partnership has been really great. So Girish and team have been working with us very closely to get the solution developed. They've also helped out add new features such as audio support, which we'll be rolling out for our cameras very soon. So that's kind of describing the two iterations of where we were and where we're going now. And so, Charlie, I'll turn it back over to you.
Great. So now let's flip it one more. Time for questions. And I imagine most of the questions will be for, well, I have to wrap up. Oh. So we talked about, as we did before, there's a couple of things going on here for you to keep in mind. So you need to really understand that we're in the midst of this, what we think is a revolution around connected devices. And you need to innovate in order to differentiate yourselves and get there faster. And Comcast just told you a story how they got there, and they're continuing to innovate. So that's the story, and now we're opening up to you for questions.
So you're doing Kinesis video streams right now, and you just mentioned audio as well. Is there something in the roadmap for two-way audio, like to the camera and back from the camera?
So the question is there anything on the roadmap in Kinesis video streams for two-way audio? I don't know the answer. Yep. Yes, sir.
Just wondered what other type of devices do you have plans for, and taking advantage of similar devices in that area?
I think primarily we're focused on camera right now. I think the question was for the Comcast team is to, what was the question one more time?
Yeah. What are the devices?
What are the devices, are we planning to take advantage of? But right now the focus is on cameras and KVS, and if anything changes, you'll find out, I guess.
What is the price point for this for a single-family home or a 5,000 square feet home? What is the price point?
So the question is, what's the price point for your home service for, say, a 5,000 square foot home?
I honestly don't know, but I think it depends on the number of cameras you want to buy. I think the information is available online. You know, if you go to, what's that? That's good to know.
I pay something like $35 a month for
Yeah.
Xfinity Home.
I think it's
but it
based
doesn't
on the
have
number of
cameras.
cameras you have.
Yeah,
In a nutshell, that's what it comes down to.
So it's not based on how much you stream or how much video you're sending up there, it's just based on camera?
Yeah. So in a nutshell, I think if you can imagine 5 cameras in a home, you know, ideally, you know, what would happen is, you know, you'll probably enable 3 of them to be CVR enabled. So you're pretty much paying for those 3 cameras at that point. Yeah. Because you're buying the cameras. Once you buy them, it's yours. Right. And after that point, it's pretty much how many services you add on. Yeah.
And I think the point to be made there is that KVS is allowing us to be competitive in this space, right? Because since you're not charging for upload or how much you stream or the quality of that stream, having a very cost-effective solution is something, like we're always looking to drive down costs, right? Because those costs aren't really going back to the customer, it depends on how much they stream. So in order for us to be competitive, we leverage services like KVS to help keep those costs down.
What's the retention period for the video?
The question is, what's the retention period for video?
I think there are 2 schemes that are out there. I'm really not sure. You know, we didn't pay attention to that before coming to this summit. We focused on the technology here. The information should be available online. You know, I'll be glad to show you the website once I get on stage.
I saw you were doing H.264 compression on KVS. Are you compressing the input stream coming into the system as well?
So the question.
Question for not really. Well, you know, we store it in KVS and we retrieve it from KVS. You know, we don't touch the videos at that point, right? So.
But when it comes in from the cameras to the network?
So I think it's a variable bitrate. You know, I'll take a stab at it. I think, you know, what we have done prior is, you know, depending on whether there is motion in the video or not, you know, we change the bitrate. So we don't want to store high resolution bitrate on a, you know, for all video, right? I'm having a hard time looking at anything so with these lights on. But what we used to do prior to using KVS is we adapt the bitrate. So if there is high motion, we try to increase the bitrate. And if there is no motion, we lower the bitrate and store it. But with KVS, I think we still do it. I'm keep looking at Kirishi. But I think we still do the same thing, but I'm really not sure.
Question.
This question is more about like your team. So when you decided to go all in AWS, can you talk about what kinds of things you did to make sure the development team had the skills and knowledge to implement this?
Right. So the question is, you know, what kind of skills did the developers need to learn before we, you know.
Like what did you guys do to make sure they had the skills they needed to do the work?
Right. So the good news was, you know, before we even started working on AWS, you know, obviously the team was well versed in OpenStack, and that was a pretty steep learning curve, considering that, you know, OpenStack is nowhere close to the maturity. This is 5-6 years back. I honestly don't know how good they are right now, but considering 5-6 years back, the team went through a steep learning curve, trying to use OpenStack at you know, within an internal cloud system. I think, you know, we had like 3 or 4 primary engineers that we worked with. It was not a huge team like we have right now. And then we worked with another external provider. So by the time we got to KVS using Amazon, the team was pretty, you know, deep into, you know, adapting to cloud technologies. And KVS actually and AWS made life a whole lot easier for us simply because of the maturity of the tools that they have. I guess this should vary from team to team, but our team adapted pretty easily. And we didn't have to go through any additional steps to make them go through the process.
And this has been a bit of an evolution for us, right? So this isn't a big bang that happened all at once. So the team had lots of experience with S3, and then when they moved over to EC2, they got experience there. One of the things I didn't mention is when we rolled out the solution, we actually have a capability of rolling back and forth between S3 and KVS, so that if we did experience any issues. And so the team got very experienced in terms of being able to flip back and forth between those. So I think the key point is definitely an evolution for us to get here. It wasn't a big bang.
Question.
Yeah, mine's on security from a Comcast perspective and a homeowner perspective. What is the stop, or can you notify authorities if a hacker or a person that has ill intent to be robbing a home? You know, nobody's home.
Right now, I honestly don't know the answer to the question, and I would like to leave it at that for now, because we don't have any plans right now to deal with this specific situation. But I honestly don't know what's in the roadmap, so I would defer to a later stage to answer this question.
Other questions? Well, thank you. And if you wouldn't mind, fill out the session survey in the mobile app so that we can keep tabs on what you think of what we're delivering to you in the way of content. Thank you very much.